All right, so we are joined all the way from Cambridge, Massachusetts, by my friend Vaughn Horn with the Broad Institute, project manager there with the Broad Institute. Really one of the authorities, as far as I'm concerned, when it comes to CAD and architecture and all the construction planning, engineering things. We are recording this for our all of our computer science engineering students in Madison County schools, and all the middle schools, all the high schools in our YouTube channel. And I've got a room full here with me at Belma Jackson High School. And as always, we thank you so much for joining us today.
Yeah, my pleasure. Thanks for having me.
Yeah, and like we said, you are with the Broad Institute there in Cambridge, Massachusetts. But before we see some of the stuff you do and talk about what it is you do, talk a little bit about how you started in this career, because it's a career that, one, that's not going away, but two, is going to keep growing because of the advances in technology.
Yeah, I'm an architect, and here at the Broad, my position as senior project manager is on the architectural end, tied into the facilities group. Um, in in the field, you might call me an owner's rep. Owners of buildings such as these are ambitious in terms of the construction projects that they pursue, and any people such as me, architects, who have had experience with projects of this scale, if not bigger, to manage projects, to work directly with architecture firms and with construction managers and different consultants that are interrelated, including the engineers, electrical, mechanical, plumbing, working with those engineers in order to complete projects and to complete everything from very small renovations to large scale renovations, and including some ground up construction of entire buildings that I'm not part of very specifically for the Broad, but I have been in the past for kind of the bigger buildings. These days, it's been kind of the gutting out of entire floors by demolishing office buildings to make way for science, to make way for labs and those supporting spaces, the lab support rooms. Has been a big part of my day to day.
Yeah, and that's really cool, because the Broad Institute is one of the most influential medical groups in the country. But you're not a medical person, so that just shows
Right.
that these technology and engineering, architecture jobs are really needed throughout all types of industries. Because, like you said, as technology changes, as science changes, they need new space, they need new areas for their equipment. And I know the Broad a few years ago built a 15-story building that had to be housed for the research there. So it is amazing, because you just think construction business, but there really is a far-reaching need throughout several industries.
Right, correct.
Now, and I know you're a big CAD person. You do a CAD every day. You've done a lot of interesting stuff with it, and we've kind of scratched the surface with it here, and it is part of our curriculum. But I think they really need to see and understand how important it is, and some of how these projects start, and some of the ways that you use it.
Yeah, CAD, in the sort of CAD terminology in the broad sense of computer assisted drafting, that is part and parcel of what I do, what's interrelated to all the different trades. And whether it be AutoCAD as a software or whether it be Revit, Revit has what is integrated as building information modeling, and that is an offshoot of what we had known as AutoCAD, which tended to be for architectural purposes two-dimensional, meaning that you would see a floor plan or an elevation or some kind of technical drawing like that drawn as two dimensions. And with Revit, you have the opportunity to have that information displayed that way, but it's drawn in three dimensions with something that represents a wall, something that actually represents a chair or represents a lab bench that a scientist might use. Even a light fixture would be shown in Revit. Those sorts of things I work with between AutoCAD and mostly Revit these days, because most of our consultants and sub-consultants, they all work in Revit. And so you need it. You need it to not only document, but also to communicate with each other. And let's see, I think I wanted to pull up an example of a Revit model, um, if it allows me to do that during using the screen share. It's kind of a big file, so it's still opening in the
Sure.
background.
Now, and
But
while we're waiting on that, I also think, in a place like the Broad Institute, there's several millions of dollars at stake. So having this stuff planned correctly to get to the construction phase is vital. So
absolutely.
the people, before you ever put a hole in the ground, the CAD people, the architects are just as important as the people putting it together.
That is absolutely correct. Because you can't actually do any of that work without the precision that's involved with the drawings that you create, and all of the different trades that are involved, all of the different groups, the different disciplines are all going to be using, kind of what they see, they want to see, and what they understand needs to belong in the building. Beyond furniture, there's electrical, there's, all of the duct work. Everything that makes the building go around has to actually be documented. And so I'll show you something very quickly. I don't know how much time I have to share,
I'll sure take it.
because I could go into a lot of detail. I don't want to put everyone to sleep. So in this software here, this is called Revit, and Revit uses the CAD, being the computer assisted drafting, to do documents, to do floor plans and things from there. It takes what AutoCAD has the ability to use, three-dimensional components as well. But this one I actually built from scratch. It's the entire building of 415 Main Street. So all of these components that show and represent the building, I had to make those.
Wow.
And including I pulled some of these out to the side for your students to see. You can kind of see all of this in the building is important to get right, because say if this is Greg's office here that I'm highlighting, and he needs something like as simple as a new desk, the dimensions need to be right. If you want the entire floor for yourself and you say, well, I'm hiring 40 people and we're all doing experiments on, say, rats or something like that, you need all of these things that go with that on that floor, and it has to be exact, because it needs to be ventilated, it needs to be well lit, it needs all of those conditions. And that's where something like Revit allows multiple disciplines to talk to each other at the same time in what's called the Revit model. And this is all part of building information modeling. And another piece here shows some AutoCAD that I had brought in at 2 dimensions that shows a desk and a chair. And I'll show it from sort of a top view. Hopefully, I'm not sure how it looks on your end. But in this 3D view, you can see here's what a floor plan of an office looks like.
Wow.
These sorts of things we have to draw and deal with all of the time. So I think I kind of have it centered. So you can see there's 3 people in this office that have 3 different desks, right? And that's in AutoCAD. And then in Revit, in order for it to make sense in the Revit model, which reads 3-dimensional components, you actually have to build these. So these are real chairs that I had to design and model myself.
Wow.
When I say the word model, 3D modeling is an entire sort of sub-discipline within building information modeling, which some of it you can do in AutoCAD, but it's important because these represent real desks. And even though they're showing up as sort of gray on the screen, you can go into a lot of detail. You can go into the detail of like where the drawers are, what the finish is. Is it maple? Is it oak? Is it metal? Where is the metal? Where do the screws go? Wow. And when you start moving things around in offices, you can't just do that without having this basis. And the basis or the source of truth in a Revit model is very important. And I have something else that I wanted to share if you gave me just
Sure,
a couple of seconds.
sure.
The importance of the sort of cross communication is when you have something like an entire floor being renovated. So this software I'm using right now is called Bluebeam. If you're familiar with Adobe Acrobat that reads PDFs, Bluebeam is very similar, but it's very specific to what we do in architecture and construction related fields. So this kind of shows like a sequence of drawings that are generated in Revit but are shown two-dimensionally. And I can try to pull up a couple of the floor plans. As you can see here on the left, these show all of the different floor plans from all of the different trades.
Wow.
So I will give you just a glimpse of the lab plan. So what's shown here is what's called an enlarged plan. It shows at a scale, which gives you a reference of how big an object is relative to another object. So this object, if we were to say is a door, you know, a door is about 3 feet, roughly 3 feet, maybe 3'6" wide. You know that this, what's called the flex lab, is significantly bigger than your door. And the door symbol is shown here with the dash line that indicates the door swing. And these sorts of things are very important. Every single line in a CAD drawing, whether it be AutoCAD or Revit or otherwise, has a meaning. They all communicate so that when you are actually building this stuff, the person that's installing it knows how big it is, where it goes. And when you're ordering this stuff, say from a door manufacturer, they know how big to make it because they're making it at their own shop in
Yep.
some big warehouse.
They're going to make it according to the specs that you give them.
Right, and they're going to ship it to the location, and then an
Wow.
installer is going to have to install it and hopefully not have to modify it, meaning make any changes once it lands. So if it's precise, if it's accurate, it'll all work out.
Wow.
So what's shown here for everyone's reference, these are all symbols, but they all represent real objects that have to be ordered and are now being installed. So what's called a bench or a sort of a lab bench is shown in these kind of rectangles, and these dashed lines all have meanings. The ones that I'm kind of highlighting or circling now, these indicate where the drawers underneath the bench belong. And these lines here in the middle show where the gases are run. So if you're saying, if you're in like Mr. Johnson's physics class down the hall from you, and you're trying to plug in a Bunsen burner, the Bunsen burner runs on gas, and it needed to be placed at some point in someone's architectural drawing so that it was in the right place so that you could sit down and have your Bunsen burner and do your science experiment. Same sort of logic here. Your students are probably familiar with symbols such as a sink. So this is a lab sink. This shows up in Revit. It's actually drawn in 3 dimensions, but you're looking at the top view from the plan. So this is the top view showing the drain. You know, this is the drain and that's the faucet. This is the emergency eye wash and this is the sink. And all of these have components, if you will, pieces to them that are based on manufacturer specification. It all goes into a CAD drawing, whether it be AutoCAD or Revit.
Wow.
Now, yeah. And then what starts to happen is, say, what's happening right now, right before our call started, I was working on one of these microscope rooms. The scientist that's moving into the microscope room has an idea. He wants to bring in a very specific high-powered laser microscope, but it requires something to be suspended from the ceiling to house some of his equipment. Now, construction is pretty far along, and he gave us this recommendation like last week. So you can imagine all of the trades, the mechanical, the electrical, the plumbing engineers have been in and out of this building for a few months and are close to done. It's November. This is supposed to open around New Year's Eve.
Wow.
So what we had to do was try this new design version of a design exercise, if you will, to figure out, is it going to fit? And so what I've been working on is I was taking an AutoCAD drawing and I was trying to figure out where would this rack go in the room. And I needed a CAD drawing in order to understand that, because I also needed to go to the construction site and figure out where does that correspond compared to where it's drawn.
Wow.
And so in this plan, it shows these symbols in CAD are for sprinkler heads. And we're all familiar with those. We need those. There's a fire, that's the fire suppression system. These symbols are for what they call diffusers. That's for AC. Imagine life without AC. But imagine that in a right. Imagine that in a lab room with a very hot laser and equipment that's connected to it that also runs pretty hot. You need AC. But what the scientists didn't understand was that there's all these different things to consider. Like if I were to take off, these are different layers here that I created on the side.
Wow.
So a mechanical engineer, this is where they get down. They start seeing like, oh, we are running all sorts of ductwork in the ceiling, and these symbols all represent ducts. So these are real pieces of equipment that are heavy and big, and you can't just move them around. So if someone comes to you and says, let me hang something, suspend something from the ceiling, you have to say, wait now. There's a lot here. So the first thing you do is go back to the drawings, which are drawn in some sort of CAD version, either AutoCAD or Revit.
Wow.
What we found was that some of these large ducts are very big and they're running right through the space. So he has a very confined footprint for something suspended from the ceiling. And then a plumbing engineer, they would draw what goes into that room from their perspective, which is all wastewater pipes, cold water pipes, drainage pipes, all of those things, high pressured air. That all serves laboratory functions, and that needs to be drawn in an AutoCAD drawing. So I had to what they call overlay. I had to overlay all these different drawings so that I could help the contractor, the builder, understand you have a very narrow footprint to work with to satisfy the scientist's request. And in order to do that, it has to avoid colliding with everything else that's already being built, all the pipes, all the ducts, and the light fixtures.
Wow.
And yeah, and so without CAD or some version of CAD, there's no way that I'm able to communicate this.
Yeah.
It's fundamental to this. So it helps me understand, like, if I were to draw it from the front, like here's the door, and you know, a person would be, I don't know, say about this tall. You know, say a 6-foot person or maybe someone slightly shorter would be about this tall for scale. So you have to understand that whatever that the scientist might want has to be far enough from the door that it makes sense, far enough below all of the ductwork and all of that that's running in the ceiling. And it has to be tall enough so it doesn't hit someone's head if they walk right past.
And then also, there's also building code laws, vary from state to state, that would have, you know, whether they want it or not, a building of certain types has to have certain codes to be within the law in the Commonwealth of Massachusetts.
Right. And one that's universal is that anything for head height, if you will, is 6'8". Any person walking underneath an obstruction that's beyond 4 inches from a wall, this sticks out 3 feet, needs to be at least 6'8" to be cleared. Now, if you have someone that is 6'8", you know, it's the exception and not the rule.
Yeah.
Most people are shorter than that and can clear that without having to duck their head.
Wow.
So that's where I'm attempting to draw this to communicate an elevation, which is sort of a front view. If this is the door and this is where the scientist wants the rack, how tall does it need to be in order to satisfy the code requirements for that? And it needs to be far enough from the door so that someone who's blind doesn't take a hard right and knock their head right into it. So there's things like that for every line that you have, you know, in a drawing, it represents something real, and it has real considerations.
That's incredible.
Yeah, so I didn't want to go too deep into that, such as not to bore everyone, but
That was
that's kind of
really cool.
an example.
That was really cool. Now, before I get to the students' questions, I'd like to know, how often do these software programs update? Because obviously, anybody in a technical field, you're
Mhm.
constantly learning new things. So,
Right.
how often do these update, and you have to stay on top of this?
Yeah, thankfully, Autodesk is on an annual basis. So once a year, you will see actually looking ahead, there's already the 2023 version of AutoCAD and Revit. The things you have to be mindful of is for every update, there's subtleties, there's nuances that um, are meant to improve the program. So for even for Bluebeam that I was using to kind of show you guys those drawings, that even is updated regularly. But for these major updates for AutoCAD and for Revit, they'll give you what they call release notes, and the notes will tell you what's different. And sometimes it helps, and sometimes it's not so helpful. I know, like in the Adobe programs, when there was an update to Adobe InDesign or Photoshop a couple of years ago, it actually made my life a little bit harder because it took away a shortcut that I used to use all the time in the update. Not sure why they did it, but you know, someone above my pay grade makes those decisions and sends it out to everyone and says,
Software people
"This
are a
is."
different breed. But I do have some questions from the students. I'm gonna get to as many of these as I can. This first one is Layla Young. She's a senior. She's our Miss Velma Jackson. She's wanting to go to Spelman College. But
Right.
she asked, once you got into your career, did you love it more once you got in? Did you love it more once you started?
Ooh, love is a strong word. My love for architecture is unwavering, and I think my appreciation definitely went up. The difficulty of putting something like this together, even on the smallest scale, I began to gain more appreciation as I saw what it took to make it happen. And I didn't take it for granted as I might have when I was very young in the field. Only really seeing the glory, the glorious thing being built, not the dirty work. The dirty work makes for a different sort of loving relationship. It's do you become a lover of the craft of the process, or do you love what you have created at the end, or do you love the whole thing? And so it's a layered question, but I appreciate it. So I think the appreciation went up. The love is always there. It's been there since I was, say, maybe 9 years old.
That's awesome. Well, that's a great segue to this next question. This is Justin Clerk. He's a senior also, and he asked, "What type of sense of accomplishment do you have when you see a project finished?"
I can tell you, it's very rewarding. From my very first project as an entrepreneur with my own firm, very young in the game, designing a home remodel so that it become a hospice.
Wow.
I went and toured that and saw the skylight installed that I wanted to make so that someone in their last, days in a hospice care could have some daylight coming in from a place other than the bedroom window. To see something like that brought a lot of pride. To see the recent projects, to see this sixth floor lab construction more than halfway done brings a lot of pride. The pride is in my mind, the pride is in the fact that I played a crucial role in this from the very early decisions when those were all offices on that floor, on that side of the floor, to seeing all this laboratory equipment going in there, and that some really cool science is about to come out of this for sure.
Yeah, and then and even though you're not a science person, being able to contribute to scientific breakthroughs
Right,
is got to be awesome because you're the one that facilitated, but then to have the space to do it, which is super cool.
right. Which is why when I was showing you the example of the laser, you have the scientists with the capacity, probably with some earth, some groundbreaking, earth-shattering science, I can't tell them no. I have to say, like, well, let's figure this out.
This is Brian McMurtry. He's also a senior. He asks, when it comes to planning and designing structures and pipes, how far ahead do you have to think and plan?
That is a great question. I would recommend at the very beginning of the project that be part and parcel of what you do. For every room, it has to be connected to a system in a building, especially a large commercial building such as this. So as you are planning, as you are designing, you are also thinking about, if you're an architect or you're just sort of a generalist that's thinking about everything, that might be an engineer. You can't do that in a vacuum. You must be thinking about that at the very beginning. You can't wait till the design phase is done to start integrating these things. If you have to know, if you move a wall or change a room, it has implications on every single thing from where the sprinkler heads are located to, because that's running off copper pipe, and copper is very expensive. So you want to think about all of those things. But you really gain that as sort of a seasoned professional, but you're not really necessarily taught all of that in school. You have to get that experience or seek it out and train yourself.
Yeah. Now, I ask all of our guests this about the same thing, and this is a question from Jacayla Page. She's a sophomore, and I always ask this, and she asks, "How many times do you have trial and error when you're designing a building?"
Oh, it's you'll find a lot of errors, and that's why there's insurance in place as a professional to cover you. So make sure you get errors and omissions insurance for whatever you do. For a licensed architect practicing, it's a requirement, but it's because things like an omission can happen. You can get far along on the project and say something on the third floor you designed out of a 15-story building is your mistake. You own that mistake. It's your drawing, and you have to rectify that within, even if you've been paid in full. And so that's part of the game. But they happen all the time. Omissions like, not being told all of the information, that happens all the time. It's not every day, but I go into a project anticipating it. I know it's coming, so it's not a surprise. So the sooner you can sort of get that, but honestly, in your matriculation, as you go through education, you're going to be shielded from a lot of that, and you'll be placed in positions where you're learning other things about design, from theoretical to sort of artistic, and somewhere in between. And it's only really when you practice, or when you're in the field or at a job or apprenticing or some sort of other job access program, that's where you'll start seeing the errors and the omissions. And they have real gravity, real weight, because it's related to something real that someone paid for. And it's sometimes a matter of safety if you get it right. If you get it right or wrong, is the building going to be safe, or what part of the building safe or unsafe?
Yeah, and nobody in any engineering field gets it right the first time. And
Correct.
that's what I see with these kids. If they don't get it right the first time, oh, I quit. It's too hard. In these jobs that never happens.
Right. I would just tell them to quit quitting. Stop.
Yeah.
Stop trying to quit.
I've got one more from the students. This is Jasmine Williams, and she's a sophomore. And she asked, "Have you ever had an assignment that was so hard that you thought you wouldn't be able to complete it?"
Yeah, that was called undergrad. So my and then my doctorate, my dissertation. Yeah, second year undergrad architecture, I wanted to quit. I couldn't get it right. I didn't understand how to make a precise model. My classmates seemed to have gotten it. A lot of them did. Or at least my mind was telling myself that. And, grit got me through that, not skill. You were gonna have to cut off my hand to get me to stop, but I almost did, because it felt like the moment was too much and that I had exhausted all of my sort of skills. But then I started to think smarter, if you will, and got resourceful. And that was just, part of that moment. But they've come all the time, where there's things that make you want to pivot I'd say before you pivot, just see it all the way through as far as you absolutely can. But no assignment is too big. I mean, it's created by someone who also had an assignment when they were assigned something. So you think about it in those terms, how did they make it to be the assigner? Yeah.
Great point. Now we're almost out of time, and we thank you so much for taking some time for us today. But one thing that I really wanted to hit on is that the trend is changing, because this was a very, very big glass ceiling field for the longest time. But there is a growing number of women in this field, and there's a huge growing number of minorities in this field. You're living proof of that. You're one of the, you're in there, one of the most well-known medical spots in the world, doing what you're doing as a Black man, which is incredible in itself. And that's a huge congratulations to you. But before we go, just let these young people know, why does architecture and design need them to get involved with as young people now, for the females and the minorities that are watching now and watching later?
Yeah, I think that one's a loaded one. I could probably take 2 hours to answer entirely and still wouldn't miss the mark. I mean, there's entire conferences dedicated to this very question. I would recommend, if your school or school district have the resources, to send some students to the next conference of the National Organization of Minority Architects, NOMA. It was in Memphis this past year. It's going to be in Portland, Oregon next year, but it moves around. But getting to the root of that question, in my mind, is beyond representation. It's bringing a cultural perspective in how you see the world, and using that to bring some sort of change, positive change, in the way that we do things. And that comes from different perspectives that were at one point in our very recent history muted. Women in architecture being, sort of blocked from having promotions. Black men and women in architecture, the ceiling wasn't even glass; it was concrete. You were never getting, unless you started your own business. Now, if you feel that strongly, there's always room for entrepreneurial interests, especially in architecture or the related fields. And if you were to pursue that route, you create your own lane, and you run into different ceilings, like getting loans and getting clients. So it depends on how you want to sort of what arena you might see the highest value. But I think in terms of representation, it doesn't just matter. It's necessary.
Absolutely.
And the voices have to come from all different places in order for, I think, projects to truly sing, but for our field to actually make sense.
Absolutely. Couldn't have said it better. Man, and I know you're really busy, but we always thank you so much for making some time for us. One of the most intelligent guests we've ever had. I'm just blown away with all the stuff. It's so cool.
You're too kind. I don't have any money if you're trying to butter me up. I'm just kidding.
Just no. So incredible, all the skills you have and all the great stuff you do up there in New England. So again, Vaughn Horn, all the way from Cambridge, Massachusetts. Thank you so much for joining us today.
No problem, and hopefully some of your students can make it over to see what the students at Tuskegee are doing.
Yeah, that would be great. And we, like I said, our salutatorian from Velma Jackson last year is a student at Tuskegee now. So we are represented over there. It's a great HBCU.
Love it. Sweet.
All right. I'll talk to you soon, my friend.
All right. Thank you.